Hello, everyone, and thank you for coming. We have a special guest for today's workshop on C# Smart Contract Development. With us is Harry Pearson, also known as DevHawk on the Neo Discord. He is responsible for maintaining the Neo Blockchain Toolkit for Visual Studio Code. Beyond the day-to-day with NGD Enterprise, he champions the importance of providing a best-in-class developer experience. Harry, are you ready to start your presentation?
I'm as ready as I'm going to be today, Robert.
Okay.
I'm as I said on Twitter yesterday, I had hockey last night, so I'm tired this morning, but I'm in a very good mood because we won. So that's always helpful. So today, what I was planning on doing is to show off perhaps some of the aspects of the Neo Blockchain Toolkit that you may not be as familiar with. I tend to work at the command line. Most of the time, it's just the way that I have learned over the years that I am most productive developing. And I wanted to show off a few things. Obviously, we will still use we'll be using Visual Studio Code. We will see the debugger. We'll see the dev tracker. But I also wanted to show off a couple of other things. And I figure we'll also take questions, right? Won't that be part of this, Robert?
Yes, we will.
Okay, cool. So I just wanted to show off a few things to make sure everybody's aware of the capabilities that are here across the board, both sort of on the surface with the blockchain toolkit and dev tracker and under the hood. So we're going to start, of course, this is all the samples I'm going to show today are up on the NGD Enterprise GitHub repo. So we're going to start with registrar. None of the this one was actually one that was originally built by NGD for Neo Legacy that I have upgraded to Neo to N3. And so, of course, you're probably familiar. You've seen this. I have the ability to, I can get access to an Explorer. I can start the Explorer here directly from inside of Visual Dev Tracker. So if I start this, I actually have this working. You can see here I'm at height 1. So I've actually reset it pretty recently. And it'll take a second for it to come up, and I can see the chains. Of course, there's nothing that's actually happened in this blockchain yet. So, this isn't actually going to be very interesting here. So we'll get back to that in a second. What I'm going to do is I'm going to rebuild. One of the things about Neo Express and the blockchain toolkit is that one of the philosophies that I work on is the idea that developers need a constant state to be able to test against, to be able to work against, and what have you. And so everything that we do, or a lot of the things that we do in the blockchain toolkit, we do in order to make sure that developers can have this consistent expected state to work in. It makes for both debugging and testing, simplifying debugging and testing in a way that the less you know about your system, the harder it is to do those things. So the first thing I'm going to show off here is something that's called the batch mode. And you may be familiar with it because most of the samples that we produce have some kind of batch mode operation. The idea here is that we wanted to be able to get the blockchain in a consistent state as quickly as humanly possible so that we can actually do it during the build. If you look here in the registrar file, okay, let me just run this compiler. Maybe I just have it on the tool. Oh, I know what's happening here. So one of the things there are going to be a couple of preview things in this. I just realized, of course, that this is in a slightly different state than the version that's up on GitHub. One of the things we're shipping, for those of you who aren't aware, we're getting close to shipping version 3.2 of the Core Neo platform. Every time there's a new release of the Core Neo platform, we ship new tooling to go with it, right? Because of course, all of Neo Express in particular is a sibling, if you will, to Neo CLI or Neo GUI, the full node implementations. You can use those tools to build your own local development node, but it's of course a large amount of effort. And the whole point of Neo Express is to make it very fast and easy for developers to bring up their own node for development purposes. And it, of course, supplies a variety of features that you don't get, developer-focused features that you not only don't get, but would not want on a production blockchain. I don't want to be able to easily reset, mainnet to Genesis or to some previous snapshot. That would be bad, obviously. So these are tools that are specifically for local development. Anyway, but one of the things that we're doing as part of the 3.2 release is we're actually improving the build experience. So you'll notice like this file doesn't look very different from a normal. This is the project file for the registrar sample, and if you've looked at it in the past, it's been pretty complicated. If we bring up what it looks like normally via GitHub, this is what if you go and you look at master branch on GitHub, you'll see that there's a lot of stuff here and I'll be the first to admit that MS build files are kind of a black magic to work with, and it's very difficult. And of course, part of the idea that we always want to do with the blockchain toolkit is take every little rough edge and sand it down as much as possible. And this big, ugly, complicated build file makes it harder for developers to be able to maintain their system. So one of the things we're doing in version 3.2 is we're actually shipping an updated set of build tools. So you'll notice here that I'm specifying a contract name and I'm specifying a path to the batch file. And this automatically triggers both the compilation of the contract as a NEF file, that's the binary file format that we use for compiled contracts, and it's going to, I guess it didn't actually run the batch file. So tell you what, let me just switch back to master here. That would be better. That will actually, as I said, I'm not quite on my A game because of hockey last night. Sorry guys. So let me rebuild this. You'll notice how, yeah, we do not need these warnings. And you'll notice here that as part of the build process, we're actually running a set of contracts. Ignore these warnings. Those are, that's not a big deal. You'll see here that we reset the node, and then we're doing a set of operations. We're doing a set of transfer operations. We're doing a deployment. We're doing an invocation. The way that this specific sample is set up, it resets the blockchain every single time you build. But it's fast. It only takes a few seconds to actually get this up and running, which is part of the reason why it's so important to actually do this build do this update as part of the build process. That way you're always working against an accurate version of the blockchain. And it turns out that we use this information in tests. If we look at the actual batch file, you'll see here that these are the steps that it goes through. These are the exact same operations you can do at command line, right? So you can transfer, what have you. So we're transferring gas over to a variety of different accounts, Owen, Alice, and Bob. Obviously, Alice and Bob, we're all very familiar with Alice and Bob. Anyway, so we do these blockchain operations, transfer, contract deploy, contract invoke, but we also create checkpoints. And we use these checkpoints for test purposes, for debug purposes, and what have you. When we go to walk through the debugger, we have a launch configuration file. And the launch configuration file in many places will specify a specific debug checkpoint file. So for example, we have this file, this debug configuration called register. Register will do a register of sample domain for Bob, and it's coming back again. And then we have this.
Why that's happening? I'm really sorry, Harry. I've muted absolutely everybody in the session, but
okay, I don't. It's very strange. Oh, now it's gone. Okay, Sam just muted, so I think it was Sam. So okay, so we're back to this. Sorry. So we were just talking about these launch configurations for this specific sample, and you'll notice that one of them is called register and one of them is called register fail. And so the idea here is that we're going to be able to test both the success and failure modes for the register operation in this sample contract. And this one does not specify a checkpoint, and this one does. So what we're able to actually do here is we're able to actually use these checkpoints, which were originally created so you could easily roll back. You can actually run the blockchain live against this version of this data that's running in the blockchain, which is a really powerful tool for test purposes. You can even run, by the way, you can actually even run the blockchain checkpoint directly, right? So if I say, so one other thing real quick, a quick aside. One of the things that I do in all of the samples that I demonstrate is I use what's called a local tool for all of the developer features. So NeoExpress, the blockchain tool, the Neo C# compiler, Neotrace, which we're going to see here in a minute. These all get installed locally to this project. And the reason that works this way is because this way I can actually have different versions. And of course, for me, since I'm usually in the process of developing and have random things happening in random projects, I can't really work with a global instance of these tools very easily. And so the samples are set up this way as well. In fact, you'll see here that if I scroll up a little bit, it goes through and I've run a Neo.NET tools restore. So apparently I mistyped it here. Well, let's just do it again so we get that error out of the way. It checks to make sure that these various tools are all up to date, running available in the system. So when I go to actually run the command, I can say, instead of typing NeoXP directly, which will pick up the global version, I say .NET NeoXP. And that way I get the local version, which may be a different version than I have from other ones that are installed on the machine, or different versions. As we'll see in a little bit when we get to looking at, I'm going to do a little bit of talk about the new debugger work that we're doing. That's running a very different version of the C# compiler, or a different version of the debugger, etc. So one of the things that's kind of interesting about the checkpoints is that you can actually run them directly, right? So if I say, .NET NeoXP run, and for run, we'll just set a block time. Whoops. That's not good. There we go. Okay. I'm going to set a block time of 1 second. So that way we generate a bunch of blocks. You can see here we're at 6, we're 7, 8, 9, 10, 11. I stop this and I start it again. It's going to be right back. It's going to pick up right where it left off. So it was at 12. It picks up at 12 again, 13, 14, 15. Now, of course, these are just empty blocks because I'm not actually doing anything alongside of these operations. But one of the things that's nice about checkpoints is that you can actually run the checkpoints the same way as you would actually run a normal blockchain. So if I say .NET NeoXP checkpoint run, and I need to provide a path to the checkpoint, so we'll use this one, and I'll set a time of 1 as well. Now you'll see that we've started back at 5, and it's creating a new block. So this is a completely separate view of the blockchain starting from checkpoint 5, or from block 5, which was the output of the batch file at that point in time. If we go back to the batch file, we can see here, I click on the right file, 1, 2, 3, 4, 5 operations. Right? So there were a set of these operations that got done, and we picked up at the end of that. So it syncs at 5 to make sure that that's their right block number. If I now stop this, run it again, we'll see that it picks up again at 5, that it's already at view 5, so then it's going to commit the next block at 6. So just a little thing to think about with this is that it gives you the ability, like if you're running into some kind of issue or bug at a specific, you can get your blockchain set up exactly the way that you want it, right? Other blockchain tools will, they'll set up a blockchain and it'll have like, oh, well, we've created 13 accounts and each of them has, 10,000 tokens or whatever. And that's great. But what one of the core philosophies that we have with the blockchain toolkit is to make it really easy for you to set it up the way that you want. And as I said here, you can see that you can very easily set it up exactly the way you want, right? The commands you want with the accounts you want, checkpoint it, and get snapshots of what the actual chain looks like at the specific points that you care about. You can also use these in tests, by the way. So you're probably familiar, of course, with as part of the blockchain toolkit, there's the core parts that people are usually familiar with are going to be, of course, the visual dev tracker, right? So if we start this back up again, right, these are the kinds of things that people are super familiar with. They're used to using the blockchain toolkit. They're used to seeing, the dev tracker. They're used to being able to, get the exploration of the various blocks that are happening. Testnet, not a lot of action on testnet here this morning. but to be able to look at specific blocks, specific transactions, get the whole view of all that work from directly inside of Visual Studio Code, to be able to get that same experience inside of for their individual blockchain, their local blockchain. Of course, we are. Whoops, this is. How about if I actually click the right button? So you can get a view of the blockchain for your specific blocks. Not sure what's happening here. Oh, there we go. So that you can actually see a block, you can see an actual transaction, all of this kind of stuff. You're probably very familiar with this. You're probably familiar with Neo Express, which is happening down here. And you're familiar with the debugger. So I wanted to show off a couple of other things that are there in the toolkit that you might be less familiar with, like the checkpointing stuff that we just walked through. So let's stop this blockchain and shut these windows down. And I wanted to show a tool that you can use called Neotrace. So Neotrace is a tool. One of the things about the debugger that we're going to see here in a minute is that it actually has two modes of operation. It can work directly against live code. So if I go here to the debugger and I say I want to run the register step, what it's actually doing here is it's actually launching an instance of like a trimmed down version of the blockchain, right? So it has, it's using the snapshot if you provided the checkpoint, excuse me, and it's creating an instance of the blockchain, the Neo system. It's checking to make sure the correct version of it's checking to make sure the correct version of the contract is deployed, and it will actually go through a mock deployment if it is not. So if you were to just start up, like in this case, this is a Genesis, this chain is running from Genesis, this debug chain. So it's actually creating and deploying the contract as part of the startup to make sure that we actually have the right version of the chain. And we can step through and do all this kind of stuff. This is all happening live. So there's an actual instance of Neo VM and all that stuff running that is driving all of this experience, right? The storage experience. You'll notice, by the way, that we have added some information here, like the gas consumed and which contract, which engine we're in, what the script hash is. Some of these things are coming in the next version these are in an unreleased version of the debugger that I have installed locally. These will be coming as part of the 3.2 release, as well as for the storage. We'll see more in a little bit, the new storage preview, the new storage schema preview that's coming. The thing is that this is great if you can get your blockchain set up exactly the way you want it. But one of the things that of course happens is you get something and you deploy it to production. You've got it up on mainnet, you've got it up on testnet, and something goes wrong. So Neo Express also has the ability to create what's called a trace file. And a trace file is exactly what it sounds like. It's basically all the information about what the virtual machine looked like at every single individual step of the contract. So every single time you execute one single step at a time, and when I say single step, I'm not talking about lines of code in this view. I'm talking about lines of code in this view. So for those of you who aren't familiar, this is the disassembly view. I got to it by clicking this button here, the toggle debug view. This is the Neo VM as it appears directly inside of the virtual machine. So every single time with the trace mode, every single time you take a step like this, load arg1, load arg2, we take a snapshot of the entire state of the blockchain. So what's cool about Neotrace is that it can actually generate a trace file for a transaction that occurred on mainnet or on testnet. So we're going to come up here and we're going to look in the task file, and you'll see here that there's this task for generating a trace. And so I'm going to say Neotrace, I'm tracing a transaction, and we're going to be doing it on testnet. And just to show you that I've got nothing up my sleeve, let's go to Dora. Let's go to Dora, not Quora. And how about if I look on the testnet? How do I tell it I want to only look on testnet? Testnet. This was a while back, so this is an actual, here we are, let's just do that. So here's a transaction that occurred. I'm not sure what Dora is doing here. Okay. Dora seems to be having a bit of an issue here. Okay, well then we will not see this in Dora. Anyway, what this is going to actually do is it's going to actually download this block locally, run it, and generate a trace file for it. And this will allow me to then go back later and actually walk through it in the debugger. So I'm going to come up here and I'm going to say run task. And you'll notice that I have build, test runner, generate trace. Test runner is something, we're not going to talk about that today, but because most of the stuff I do is in C#. Test runner is a tool for running tests that enable other languages that are not implemented in C# to be able to get access to the same kind of test infrastructure that we provide to C#. But I'm going to call it generate trace. And you'll see here, it's going to run .NET Neotrace TX. And you can see here that it was in this block. And it's having it download a bunch of information, tracing that information, and it's complete. So let's see if Dora will give me a view of the transaction if I look at it from the block. Okay, so mainnet, testnet. Okay, so apparently Dora doesn't have that information for testnet, N3 testnet. So sorry about that. I can't demonstrate that it's a real block and a real transaction that it really occurred on testnet. But by running that command, we've now generated this file, trace files, and it uses the extension .tracenet or .neotrace, and it's named for the actual transaction, right? So that transaction, you'll notice here, is the same as the one here. It ends in DAD, it ends here, DAD. Now, the thing that's kind of cool about this is now, this again, remember, this is a transaction that actually ran on testnet. This isn't running locally, but I can still debug it. So if I come through here to register trace, and we look in the, let's look in the config file just so we can see what it looks like. We'll see here that where normally we say we're going to do an invocation like I want to invoke the register function and here are the arguments. Here, I'm giving it a path to a trace file. So now it's going to actually get that information out of the trace file rather than running it locally. And when I go to run it, I'm going to get, as I said, I'm not quite awake here this morning, folks. 1 second. Version of the debugger do I have? Unfortunately, I believe I have a preview version of the debugger installed. Oh, reload required. There we go. So I had the preview version of the debugger installed, which unfortunately trace files are currently broken. But we will be fixing that before we actually ship. Go figure. Okay, here we go. So now you'll notice that this experience is very similar to what we normally have with the debugger, right? In fact, it's almost identical. When I say almost identical, what I mean is you'll notice that there's a couple of extra icons that are up here on the toolbar. Step out, step into, step over. Okay, we're used to those, but what's this one? Step back. Because it's a trace file, because it's essentially a simulation, it's not actually executing the virtual machine, I can actually walk back and forth through the debug trace as I want to. So I can step forward, I can step back, I can actually go all the way back to the beginning. So this is really powerful, so that way I can get a view of what's actually happening on mainnet or on testnet for an actual production block execution. I get the full storage, I get the amount of gas that was consumed. The gas consumed, by the way, is actually part of the current release of the debugger, the part where you can actually see the current contract. That's coming in the next preview or in the next release. I can see all the variables and inspect them. Again, the same type of experience that you would get running the debugger locally, but for a transaction that actually occurred on mainnet or testnet. Obviously, you can't pause mainnet or testnet to be able to debug. Like, hey everybody, I got to figure out what's wrong with my contract, so we're just gonna stop mainnet for the next 15 minutes. Yeah, no, obviously you can't do that. So, but this is an XFX thing. You can actually run your operation in production and then still be able to debug it and get that kind of experience. Plus, you get this extra experience of being able to step through it forwards and backwards since we have this information. We typically refer to this as time travel debugging, right? The ability to step through forward and then to be able to walk backwards through the code. So That's the Neotrace stuff. I'm going to show a little bit about oracles, and then I'm going to spend the rest of the time showing off the new Debugger storage schema preview, because I want to get you guys excited about that. So I just wanted to show you that we do have some basic support for oracles in the blockchain toolkit. So one of the things about this, however, to note is that we don't actually run the full oracles infrastructure. We're not actually running an oracles node that will go out to the internet and grab a JSON file and bring it down. Again, see where my earlier comments about how we want to make sure that we have a consistent state at all times for the developer. So if you go get some random data from the internet, as we all know, I mean, the whole reason the oracles infrastructure exists is because data on the internet can change. And so the Oracle infrastructure is there to collaborate. There's a series of Oracle nodes. They make a decision as to what the right view of whatever data file you requested was, and gives it to you and submits it to the blockchain. The Oracle infrastructure for Neo Express is completely developer driven. So you make a request and it sits in the Oracle queue until you, as a developer who has full control, submits it back to the blockchain submits that information back into the blockchain. And you'll typically do that with a command called Oracle Restore or Oracle Response. So you can see here that I've got the .NET tools installed here, or the Neo Express tools installed, and I'm going to rebuild my project. And that step is fast enough that we actually do it here in Visual Studio Code. We do it automatically, and you can see here that we've also done as part of the creation of part of running Neo the batch file. So you can see here, this is going to look very similar to the last one. We're enabling oracles, right? Oracles by default are disabled, so you do have to enable them. So there's a command called Oracle Enable. We deploy our contract, we take a checkpoint, we invoke the contract, we take a checkpoint, and then we do the response. And so this is the way, again, all of these commands you'll see in a batch file work exactly the same as they do when you run them on the command prompt. The benefit of using a batch file is that it only opens the blockchain file once. It runs all the operations and then it shuts it down. As you can imagine, that opening and closing of the blockchain does take time. It's got to open the file, it's got to map a bunch of stuff into memory. So doing that over and over, like in this case, doing it 7 times, is a non-trivial amount of time. So doing it all at once with open the file, do a set of operations, close the file, is dramatically faster. It's one of the reasons why we can actually run this as part of the build process every single time. So you'll notice, by the way, that this specific blockchain, this specific contract is actually calling out to the log. So you'll notice here that the sample we were looking at before did not, but this one is calling, shut this down. You can see here, we're calling runtime log, we're calling runtime log for Oracle callback. This is a hello world of oracles, right? I'm going to make a request to this fake path. I'm doing actors because that's just what I did at the time. So this is just a normal Oracle call. So let's actually see what this looks like if we run the commands individually. So what I'm going to do is I'm going to sit here and I'm going to run these exact same commands, but now I'm going to do it from the command line. So I'm going to say .NET, again, we're using local tools, NeoXP, contract, invoke, and then make Oracle call and Genesis. So this is basically saying I want to run the contents of this Neo invoke file, and the account paying the gas price is the Genesis account. We haven't set up any other accounts here because of the fact that it's a very simple demo. By the way, only the Genesis account. And so just as a reminder for those of you who aren't familiar, the Genesis account is essentially the council vote, right? The consensus node. It's the same account that signs every block that comes along. And this way, because the Genesis account is what receives the 100 million Neo that is created on Genesis of the actual blockchain. So we're just using that as a shorthand. You can't actually create an account called Genesis that automatically gets blocked. So this way you can always refer to, like, this is what you use for administrative operations and like enabling oracles. So if I run this operation, we'll see here that it made an oracle call, By the way, you'll also notice I don't actually have the blockchain running. The blockchain is in what I call offline mode. So every time you do an operation that's going to modify the state of the blockchain, it checks to see whether it's actually running or not. And if it's not running, what it's going to do, hold on a second here, I forgot to turn off my phone. What it's going to do is it's going to basically create a block with the individual single transaction that you created and submit it, right? Of course, because this is NeoExpress, we have access to, this is the NeoExpress file. I have access to the private key of the nodes. This is a single node blockchain, but if this was a multi-node blockchain, all of the consensus node, multi-consensus node blockchain, I mean, all of the private keys are available as part of NeoExpress. Remember, NeoExpress completely and utterly unsecure. So do not use these accounts on mainnet, on testnet, unsecure by design. But because I actually have access to all this information, we can, the same way that we sort of create a little stub blockchain for the developer in the debugger, we can also create a little stub blockchain just to get it up and running enough that we can submit a block and persist it. So unlike the debugger, where anything that you do in the debugger automatically gets thrown away at the end of the session, nothing is ever persisted when you're using the debugger. But with offline mode, you can actually make a change and execute it. And of course, it's very fast. If you're running the blockchain, that transaction is not going to get submitted until the whole block gets submitted. So like if you're running a blockchain with like 15-second transaction or 15-second block time, then you submit your transaction and you twirl your thumbs for 15 seconds. And you'll get surprised at how fast that 15 seconds adds up. And you're like, this is just taking too long, which is the reason why we have the batch mode and why we have offline mode, so that we can do these operations very quickly, even when the blockchain isn't running. I actually spend a lot of my time working in this mode offline because it's so much faster. Now, of course, as soon as you want to start building a DApp, right, that's great for building your contract, but your DApp is going to have to interact with the blockchain over the JSON RPC interface or something similar. So you're not going to be able to do this in this kind of offline mode. But it's great for, especially for these kind of demos, because it's a lot faster. So now if we actually go back and we look at .NET NeoXP Oracle, that actual command, we can see that it actually has 4 different commands. So I can see enable, which we saw this up here, which is basically just turn it on. You just do that once at the beginning of your, after Genesis, and you're ready to go. You can list the Oracle nodes, which isn't a very useful command, but it's provided by the underlying platform. Basically, every consensus node in your NeoXP chain also can be an Oracle node. But again, that's only really for signing. As we'll see here, when we go to do the response, it doesn't actually go out to the internet and retrieve anything. The 2 that really matter are requests and response. So requests allows me to actually get a list. So if I go back and I say Oracle requests, let's close this down and bring this up so that we can actually see a better view. We can see here that there's 1 request in the queue. Here's the original transaction. And if we look up here, oh yeah, that matches. And it's a request for this path, right? Some domain example of some path. If I go up and I say, let's run that transaction a second time, I'm going to make a second Oracle call. Now I go and I say, let's list it. We'll see here that there's now 2, 1 and 2. Now, by the way, this 1 and 2, those are the official like request numbers that are assigned by the underlying platform. It's not just like always going to be number 1 and number 2. It just happens to be that case in this situation because when we built, we reset back to Genesis. So now we're actually going to need to actually do the actually submit a response, which we do this way: Oracle response. We tell it what we want to actually do, and then the response file, which you'll notice is sitting here in the repo. And it's just a couple of actors that I pull. I don't remember where I got this information, but it's just a couple of pieces of information that I pulled off of the internet and saved locally. Right? Again, part of the point here is we want to make sure we're always consistent about what we're actually doing so that we can actually run tests. This does not actually have a test example, but you understand the concept. We can also debug this. If we look at the debug launch configuration, we can see here that we have a normal make Oracle call. Okay, so I'm gonna make the Oracle call. It doesn't take any arguments because again, it's kind of a hello world. But you'll also notice that we can also specify the Oracle response. Tell it the URL, give it the callback, give it a result file. So we can actually step through the callback in the debugger. Let's see what it looks like on the command line. So because I reset the blockchain, we don't have any requests. So let's go back and actually do the invoke again. The Genesis, the batch file is also doing both the request and the response, right? So let's go back and see what the response looks like again. We'll just pick this up. I'm going to show this in the debugger. I'm not sure what's going on there. Yes, I don't know how to do that. And it will actually do the transaction. You'll notice, by the way, that while the response file has multiple actors in it in this JSON file, part of what we're doing in the sample is we're actually specifically requesting, we're making a JSON path request that says, I only want the first actor out of this file. So that's all the information that comes back. Because all we're doing here is we're just logging that directly, via the runtime log method. So you'll notice that even though the response file has multiple different actors in it, the file that is actually shown on the terminal only has the one. So demo gods are not with me this morning. Let's take a look at the new debugger storage preview information, and let's go from there. So one of the things about, let's actually go back for 1 second. I wanted to talk a little bit about the registrar sample again. One of the things, of course, about the debugger is that in addition to being able to get access to the information that's live in memory, it also will show you the information that's in storage. So let's just bring this up again. Yes. So you'll notice here that in the variables window, we have the information about what's actually happening. Let's just do this. So for example, if I go in and say, I can see here, domain owner, there's the domain, there's the owner. The current owner is null, but as I step here, it's going to get filled in. So you'll see that it's all zeros. So there's not a current owner for this specific domain. That's just the business logic of this contract. But there's also contract storage. And this is accurate, right? There's a key and it has this information. This is a domain that's been registered, and this is the account that's registered. Oh, there's no owner for this one, but it's not very useful. It's not very easy to actually read. So this one has got one where it's actually already registered. But what's be more useful is if you could actually decode this information at runtime so that you could actually explore this information in a way that makes sense to you, the developer. Like having these big long byte strings isn't very useful. If we look at the trace one, for example, you'll see we still have the same information in storage. Now, if I take this, I can actually add this to the watch window. And if I add this to the watch window, I can do stuff like, hey, this is a byte array, but I really would rather look at it like as a address. And it will actually render it as an address. Same thing for key. If I take this key and I say, hey, let's add this to watch, we can tell it with this cast operation, hey, treat this as a string. And it says, oh, okay, well, the string is registered. So this is the owner of the contract. That's what that's what this piece of information is storing, right? When the contract is deployed, the person who did the deployment is marked as the owner. And that's, of course, a best practice that's used for being able to do update and what have you. And as we step through here, we can see here that we can put information we can see that there's no current owner. We've added a new value. We can see that the value of this string is this. I mean, again, you can go down and you can say, hey, I know that this 20 byte string is an address, so I can tell it, hey, treat this as an address, which is convenient for the purposes of working in the debugger rather than trying to decode all this information. But chances are the compiler already knows this. So could we put this information into the debug information so that way we actually get a better experience by default in the debugger, rather than having to do all this manual work of saying, oh, treat this like a string, treat like this like an address, et cetera, et cetera. So now what I'm about to show you is in preview. So it's not going to ship as part of the initial 3.2 work. It is going to ship after that. But this is what we're working on doing. You can actually run this yourself. So we're switching now over to the NFT sample. I wrote this sample originally for a devlog like this last year before we shipped mainnet. And it's essentially just a relatively simple little NFT contract. It's an NFT for people who are in the NGD community, right? So in fact, if we look at the batch file that sets this up, you'll see that I've created a NFT for Hongfei, for Eric, and for John Davidoff, my boss. He would have been mad if I hadn't included him in the list. You know, he's obviously pretty important in the community too. Now, obviously, this is silly. I'm not building a real NFT. I'm just using their image from the website as the logo. All right, so like it's not a real NFT. I'm just using existing images off the internet. But it implements the full NFT and P11 protocol and what have you. And it has a pretty complicated set of, let's switch back to main. Oh, that's not for a second. Yeah, let's stash that. It has, you know what, I'm not going to, you guys, we just saw it in the registrar sample. We know what the debug experience looks like. So we're going to switch over to the new experience that we're getting in the debugger. And again, you can do this yourself. You'll notice, by the way, that I am on the storage schema preview branch of the NFT sample. So if you go to mainnet, if you go to the main branch, it will have a link that says, hey, you probably want to switch to this preview branch. And this will have the information about how to set this up to be able to do exactly what I'm about to show you locally on your own machine. So the first thing we're going to do is we're going to set up the preview version of the debugger. So if we scroll through here, this is the list of installed extensions for Visual Studio Code. As you can see, I have a lot of different ones installed for a lot of the different types of development I do. You'll notice that some of them have this little green corner thing. In fact, if you scroll all the way through, you'll notice the smart contract debugger has that. This indicates that there's a preview release or pre-release version of the debugger that's of the extension that's available. And so we're going to actually install that now. You'll notice that I currently have 3.2.34 installed. That's the version that's up on the marketplace today. But the latest version is 3.3.29. This is the Visual Studio Code marketplace does not support semantic version pre-release tags. So using their guidance, even numbered releases like 3.2, this is the minor release, of course the major is always going to be 3, are the version are production, odd numbers are pre-release. So when we ship our next production version of the debugger, it will have a 3.4 or something like that. So we're going to see a break between the version numbering that the core platform uses and the version numbering that the debugger uses. But we need that in order to be able to do what I'm about to show. So I'm going to switch to the pre-release version. And you'll notice it installed really fast, right? And I can switch back to the pre-release version at any time. I do have to do a reload. But other than that, that's all it takes to be able to switch back and forth between the two versions of the debugger. You don't have to, it's not this big, massive, complicated thing. You can switch back at any time. Hold on one second here. Anyway, so now with this, if I go through and I say I want to debug, the other thing is that in addition to needing the new debugger, you also need to have a new version of Neo C# compiler. This is a C# contract, and so far only the C# compiler has been updated to emit the right type information for the debugger for the experience we're about to see. If we look here in the tools file, you'll notice that I have a very strange looking version for this Neo C# compiler. 3.1.1037 storage schema preview. So this is being hosted. I mentioned earlier, I like to use local tools. That allows me to use different versions of the tools in different projects. Here's why we do that. right? So I'm not using the production version of the Neo C# compiler. I'm using this preview version, but that's only works in this specific project. So if I say .NET NCCS here, I get a completely different version of the compiler than I did in those other projects, which is exactly what I want. Now, there's very few changes in this branch relative to the main branch. One of them is, hey, we want to use this version of the compiler. And there's a file here, NuGet.config, that tells it, where that NuGet file is. That version of the compiler is not published to NuGet.org, which is where most tools get downloaded from. But if I go through and I say, hey, let's see what this experience looks like, and I probably need to build. So let's build and reset. So we're doing the build and we're doing a reset of the blockchain to get everything deployed. We've seen this several times, but let's see it again real quick. All right, we've got more accounts. We're doing a bunch of transfers. We have a bunch of different operations. We are invoking the contract a few times to mint the actual blockchain, to mint the NFTs, et cetera, et cetera. So if I come through here and I run the mint operation, there's some things we're going to see that are going to be very different here. So we've seen, this code is pretty straightforward. It's going to take the name, the description, and the image, and it's going to mint a contract. If we look through in the storage engine here, we'll notice we have a very different experience. Instead of having this like random key, like a big long hex string, we actually have the name, total supply, balances, token ID. In fact, if we look up here at these, these are the prefixes that we're normally using: prefix total supply, prefix balance, prefix token ID. And we're actually able to do this decoding on the fly so that you can actually see information like, okay, there's a token. The token has a token state. Well, that's a custom type that I've got written here in my code. And if I expand that, I can see, it automatically knows that there's an owner, which is a hash 160, and then a name, a description, and an image. Name, description, image. So all the information about the rich type information, not just that this is some, collection of fields, which is what you would have gotten under the old debugger. We've actually been able to save all this information, including custom information about the types that are in your contract, in the debug information, so that you get this much better experience. You get this experience both for storage and for types that are running in memory. So as I step through the code here, we're going to validate the code owner. For example, one of the things we're going to do is we're going to retrieve the transaction. Well, now you'll notice that this variable is a transaction. So it has the hash, it has the sender. Oh, now that's interesting. Look at this. The system knows that this is a hash 160, but the system knows that this hash 160 represents an address. So it actually renders it as an address. If we go back and we look at tokens, we'll notice this one is rendered as not as an address. Now, the reason for that is that we haven't actually finished making the updates to the preview so that we can actually say, hey, treat this as an address. But eventually we get to the point where we can do that as well. What's interesting is we do have it for, because what's interesting here is you'll notice that there's a slightly different rendering of each of these different types of storage. Like total supply is a single value, so it shows it immediately. Tokens has a single key, which is the token ID. So it shows it this view where each one represents one single key, which then maps to a value, which in this case is a token state, which is complicated, so it actually shows out a list. For something like balances, now that's interesting. So balances will show a value instead of, because here it's just a simple value 3 instead of like say your token state. But you'll notice that this is rendering what looks like an address. But if you know anything about, if you know in depth about Neo addresses, this is not a valid Neo address. It's all zeros. 0 is actually not a valid character for you to use for your for contract addresses or for account addresses. Neo uses a scheme called base 58, which is designed to be easy to write down on paper and read. So it doesn't allow you to use capital O and 0. It doesn't allow you to use like I and 1, because those can be easily confused by a user. So, but we're treating this all zeros we're rendering it as N0000 to make it easy for a developer to understand, oh, hey, this is the all zero value. But you can also notice here that it's actually rendering it as an address. And that's because it's of the way that it's built in. But again, you can see here that I've got this full value. I can use this to be able to check that, make sure that the sender matches the contract owner. We can see here that the contract owner it's rendering as a, these are matching, but again, you can't because it's a preview. We've still got some bugs here. You'll notice this comma thing that's still sticking around. This value here matches this, but you can't necessarily tell that in this view. Eventually we'll get to the point where this contract owner will be rendered as an address as well. So you'll be able to see very easily, oh yeah, those match. And as we go through here, we're going to create a storage context. It knows that that's an interop of a storage context. You can't really explore a storage context at all, but you can at least see that there's that's what that object is. We can create the key, we can create the value, and when we put this information to storage, we now have 4 token IDs. We updated the token ID. That's what this set of code did. We noticed that operation occur in the blockchain data immediately. As we step through here, you can see these values that are getting filled in up here, including the token state. So we can see here that this is an actual token state. We're recreating the Hongfei NFT. There should probably be some code in the logic. There should be some logic in the contract to make sure you're not doing that, but I haven't actually done that. And then we save it to disk, or we save it to the blockchain. That's what this update balance, update total supply. And we don't actually need to see the contents of this. And you'll see now we have 4 total supply, we have 4 tokens, et cetera, et cetera. Now, the other thing I want to show here is that this applies not only for rich types like the token ID or the token state, right? That's what this code looks like. This also works for types that are like arrays and maps. So I've actually added a couple of operations, one to get all of the tokens out as a list, and one to get all the tokens out as a map. So you can see here, this is just give me a list of all the token states. I'm just gonna set a breakpoint, jump to the end of the function. And you'll notice here that I'm actually getting the information out as an array. It's called a list in C#, but it's called an array in NeoVM. So that's why it's rendering as an array. So we can see here that it's a token state, an array of token states. So it knows the type, it knows how many are in it. It turns out that under the hood, structs like token state and arrays like this array of tokens we have here are treated very similarly under the hood. But because we actually have the correct debug information, we can actually disambiguate that in the code. We can do the same thing for maps. As we step through here, you'll notice, by the way, that as we just grab information here, so the token map has, it's a map of 256, hash 256 to token state. It's currently empty. I hit this, boom, and it's already got a value. So I can see that information. What's also interesting here is that I can also do stuff like I can add this to the watch window as well. So here you will notice that I've added the token state value. This actually works better with the array version. So let's go back to the array version for now. So if I add the tokens value, you can see here that it's a value of, it's got 3. I can also then drill into it. So I can say, hey, I want the second one. So it'll show me just the second one. So there's a full evaluation for expression evaluator that's built into the debugger now, and it will automatically allow me to do the indexing in for arrays and maps, and dot into for structures like token state. So what's really cool about this is it doesn't take a lot of effort to update your contract to be able to use this new infrastructure. I'll show you the sum total of the code that we did. We've gone through the code from before had these prefixes. That's what's used to disambiguate each individual type in the storage. Is this the balance? Is this a token ID? Is this the total supply? Right? If you're familiar at all with contract development, you're very familiar with storage maps and these prefixes. All we've done is in this C# version, the prefixes are all these constant individual bytes. We've added these attributes: storage group and storage key. So storage group indicates that a given constant value prefix is going to be treated as a storage group of a specific type. You can see here, this is representing a big integer, as is balances. Tokens is for token state. The contract owner is a uint 160, et cetera, et cetera. And as you can see here, if we look in storage, there's that same exact experience, right? So total supply is a big integer. Total supply is a big integer. In fact, if we hover over it, we'll see it says that it's an integer. If we look at owner, owner is a uint 160. If we hover over it, we get hash 160. By the way, you also still have access to the actual RawBytes view. We've modified the view a little bit so that we actually show the key directly, make it a little bit easier for the user to be able to see. But we also have that same storage view. Remember, all this stuff that we're setting here, these attributes, if you get them wrong, all it's going to do is break this view in the debugger. This has exactly zero impact on the logic that stores and retrieves information from contract storage. This does not affect that at all. It only will show the code. It only affects how it's rendered in the debugger, nothing else. Now you'll notice that some storage groups have no keys, right? Token ID and total supply has no keys. It only has a single value. Something like balance has a single key, that's owner. So this is a balance of like a better example of this is probably token, right? So this token ID has a single value, a hash 256, which is the SHA-256 hash of the token. And you can see if we expand tokens, that's the key, and it knows that it's a token state. And then for some tokens, like account token is used sort of as an index. This is what powers the tokens of operation. It automatically will take out the list of, take out the owner part of the prefix and expand and return just the token ID. But I'm actually telling the system, hey, there's an address and a hash 256. As you can see, we've plumbed through the concept of address in a few places, but not everywhere yet. So as we expand out account token, we can actually see that the key has two values. One is the hash 160 rendered as an address, and the second is the token ID, which is the 256-bit hash. So all I had to do in order to get this great view in storage was to add these attributes. No other code changes whatsoever. Now, this is in preview. It's not really completely ready. As you can see, there's a couple of issues, like we haven't actually got a way to specify address for fields like storage groups and in the token state. So there's more work that's going to be done. We're also looking for feedback. You know, this is a really simple way of being able to put information about storage, but it also is completely separate from the code, which means if you change the code, you also have to remember to go back and change your storage group declarations. And that's not great. And I'd like to maybe think of a better way of doing that. There's some really great infrastructure in the C# tool chain, like source generators, where you could actually generate the source code for all of your storage reading and writing based on these attributes. But we haven't explored any of that kind of stuff yet. We are looking for great feedback from the community, like the folks that are on this call. So with that, it's been about an hour. I can stick around for a while and answer some questions. I don't know how we normally do this, Robert.
Well, normally what we do is, people, if you have any questions, please enter them into the text channel named devlog, and I will relay them to Harry, and we'll get you some answers. So if you have any questions about any of these amazing new tools, my favorites, of course, being Neotrace and the awesome upgrade to the debugger, please put them in the chat. You can also put any other questions that you have about C# development in the chat in the devlog channel. And while we're waiting for people to give us their questions, Harry, I'd like to ask you one or two myself. Would you mind explaining the -S's and SAM parameter in the NeoXP command?
Oh yeah, sure. So let's shut this down. So if you go to the terminal window, if you go to the terminal window and you say .NET NeoXP and it was run, and then we'll just add help. You can actually get some information about, these are the operations that you can actually do. These are the arguments and options that you can provide to the command. So first off, there's a node index. Of course, there's only one node in it's been my experience that while you can build 4 and 7 node blockchains, again, when I say node, I mean consensus node. 4 and 7 consensus node chains with NeoExpress, generally speaking, people usually only use a single one. But there's a set of operations. So first off is input. This is the path to the NeoExpress file. It knows specifically to look for a file named default.neoexpress. That's why I always use that as the name, because that way I don't have to provide it. But if you want to use something different, or if you were going to be in a different location, you can use input. -S stands for seconds per block. So this allows me to run the block at different speeds. So if I actually just run it normally, so let's say .NET NeoXP run, it's going to run with the default, which is 15 seconds per block. And as you can see here, 15 seconds is actually a pretty long time. And we're still waiting for 15 seconds to go by. And we're still waiting. And 15 seconds has gone by. So if you're working with NeoExpress and you submit you submit a transaction and the blockchain is actually running. So let's say you're testing your DApp and you submit we're working in the NFT sample, so we're submitting the NFT, we're minting a new NFT. It gets submitted, it gets added to the mempool. Every 15 seconds, it will go through a round where it will do a consensus round and it will actually add it, to the blockchain. And that's great, except that it's slow, and it means that every single time that you go to do the operation, you have to wait the 15 seconds. And especially with Neo Legacy, which this feature that I'm about to show dates back to Neo Legacy, it was also really valuable to be able to run the blockchain quickly in order to earn a lot of gas. A Genesis chain in Neo Legacy had 0 gas. A Genesis chain in Neo N3 has 30 million gas. So this is a much less of a problem in Neo N3. But if you want to be able to run it faster, you can actually say, hey, I want to run this, and I can tell it however many seconds per block I want. If I wanted to make it 120, which we're not going to do, right, then it would only generate a block every 2 minutes. If we say 1, which is the smallest value allowed, it'll actually generate a block every second. And so I find this is really valuable. You see here that it's generating them very fast. Of course, all these blocks are empty, but for the purposes of like developing and debugging, it's a lot easier for me, I find, if I'm running these blocks very quickly. So that way I don't have to wait a long time after I submit a transaction in my DApp to be able to actually see the results of it in the blockchain. And in fact, one of the things that's really interesting about this is if we go back and we look in the Explorer view, one of the things that we've done is we actually have an option to hide empty blocks. Now, this only works with NeoExpress, but it will automatically then filter out all these empty blocks. So if I go back and put it, you'll see here it's generating a new one every second. 62, 63, it should be, 64. It's picking them up very quickly. It's actually, the blockchain is actually running faster. And okay, it's figured out that it's running every second now. So it's generating all these empty blocks. As a developer, I don't need to see all this. But I really want to see the blocks that actually matter. So I can actually hide the ones that are empty automatically. So that way I'm only looking at the ones that actually matter. So I get this great experience of being able to get an immediate response to my operations when I submit a transaction via my DApp, but I also don't have to see all that empty blocks that are getting generated because the computer is running much faster than I am as a human being. Oh, and Edge shared a link to the transaction on OneGate. So you can see here, this is the transaction that we actually traced earlier. So it does actually exist. There's not a lot that you can see here. You can see the witnesses and the script and what have you. I really probably need to build a version of that registration one that also has some information about transaction events and stuff, so we can actually see that they match up, but I haven't done that yet. So anyway, I don't see any other questions, Robert, and we're past an hour, so maybe we should hang this up.
Just one last question, though, because I want this to show up in the video. Would you mind talking a little bit about the new debugger features and the cross-language support for them and the timetable?
So we are currently, now that we've got the C# version out, it does require a new compiler, right? The compiler that will automatically, I can't speak for other languages. C# obviously has a lot of very rich type information available. Languages like Java and Go have that same kind of naturally available rich type information. Languages like Python and JavaScript do not. TypeScript sort of, should have some, but I'm not 100% sure. We're reaching out to work with those language communities, the developers of those tools, to be able to upgrade their compilers to emit this new information. The new debugger will have to ship first because the debugger can read the old format, but of course the old debugger cannot read the new format. So if I'm taking this existing debugger and I'm trying to use say the Java compiler from the Neo W3J team, they haven't updated, and we're working with them. And as I said, this is in no means attempt to be any kind of shading on them. Those guys are fantastic, but they haven't had a chance to upgrade their compiler to emit the new format. So what we need to do is we need to work with these teams to be able to get the new format. So we're working with them. We're not going to actually ship the preview until we have at least 2, the C# compiler and some other language compilers working with the new format. Teams, if they're, for example, the NeoFS guys also run the Go compiler. So obviously NeoFS is a really important product. It's really important in the Neo ecosystem. If they were to say prioritize that, and I'm certainly not saying they have or will, I'm just using this as an example, they can continue to emit the old format. They obviously won't get the new experience, but they'll at least be able to still be compatible with the debugger moving forward. So probably a couple months. It's going to be after the hackathon for sure. But as soon as we can, we're gonna finish up the features. As I said, there's a few things in the C# compiler about emitting the correct information about addresses, and we need to get at least one other compiler up and running on this new format before we ship the preview.
Fantastic, and I appreciate that answer. And it doesn't look like we have any questions from the community, so at this point, we're going to wrap this up. I want to thank you, Harry, for that wonderful presentation, and I want to thank everybody for showing up. And my name is Robert Oshler, and see you tomorrow for the next one. Thank you.